Okay, well, we have been working on this vehicle class here that defines a type, actually defines a couple of types, has an attribute for a driver struct, and then also has, I believe, a private attribute related to miles per gallon. And just as an enhancement here, and then to give us some more code to play around with, I realized that we probably should have created a method that would simply write the driver out to the screen, and so I've created a method here called ShowDriver. This will not have any parameter passing associated with it, since it's just going to render an attribute to the screen. And so we'll write out as a new line here, and the code will be somewhat similar to something we had down here. So I'm going to go down here and borrow this code right here and move it up for this new method that we are creating, and have to make some adjustments in the data object names here. But we just want to have the ShowDriver method right out to the screen, driver equals, and then the name of the attribute it's going to be referencing is driver, and driver has a name, age and years driving, so this would be really just this right here. So my ShowDriver method is just going to write these this output to the screen for us to be able to use this for diagnostic purposes. Let's do a syntax check on that. That looks good. So let's incorporate this ShowDriver method now into our code here in place of what we have. So just to step through it here, on line 108 we have the line of code that says, okay, now we're moving from defining a class to actually procedural code that's going to instantiate the class and then use it to do things. And so on line 109 I create an object reference for this vehicle class, and then on line 110 I actually create the object. And so line 109 and 110 are a pair of lines that we will see in most, well, really in all programs that we write that involve ABAP objects. And so we call this a hi method, we set the miles per gallon, and then we set the driver information. And so now if my new method is working properly, I should be able to change this right here to a method call and say my vehicle, and I think I called this ShowDriver. And so that should now write out Bob and his information on the screen, really just like it did before, but now we have this being rendered by the method as opposed to our procedural code. And there's Bob. Not sure why we're seeing Bob and age and years driving. Oh, yes, I am sure. And this is a good thing for us to review because we talked about this last time. Why is Bob not lined up with everything else? Formatting specifically having to do with the write statement. And in fact, what I need to employ here in my method that does this writing to the screen, and this most notably comes up when we have string data, which is what the driver's name is, where we want to get rid of that extraneous white space when we are writing this to the screen. And so I believe we should now see, whoops, something it doesn't like there. Oh, it does not like where I have put this. That has to back up there. That's a mistake that's very commonly made, at least by me. And so now, well, now we still see Bob over there and age and years driving, and we're looking at variations on a theme. We've got the same thing here. We need to render this without the padding of additional spaces around the numbers for all of the elements here, because essentially what's happening is the driver's age and the year's driving is being written out padded by spaces. And so now you'll see that this one is what we just adjusted. Everything looks as we would expect there. So let's keep walking through our code just by way of review. So we set up Bob here on lines 113 and 114, and then we called ShowDriver to show us his information. So we have confidence now that he was properly put in place. And then we defined this new person, Roberta, and unlike what we did here with the set driver information for Bob, where we put in literal information, what we want to do now is we want to set Roberta to be the new driver using the variables that we created. So to save some typing, I'm going to just copy this code right here, and the new name now is going to come from the variable driv name, and the new age is going to come from driv age, and the new year's driving is going to come from driv yd. And then just like we did with good old Bob, once we have set that information, let's go ahead and show that driver. And so we now should see that Roberta is in place as the second driver, and there in fact is Roberta's information in second position. Probably would be good, for the sake of just clarity here, if we put in a dividing line. One reason why I am doing this is for your homework, you're going to have to do something very similar to this, where you're going to have to, for lack of a better expression, exercise your methods to show that in fact they do work as they properly should. So then the last thing that I wanted to do here was swap in a new driver, that being Kevin. And so you'll notice I set the old driver information here. I created new data objects. I could have reused the ones on lines 118 through 120, but I elected to create some new ones here. And the swap driver method is the most complex one that we have created to this point in this code, where what we are doing here is we are sending to the method Kevin's name, and we are getting back from the, well, we are intending to send to it Kevin's information, but it looks like what we actually did here was send it Roberta's information. I think this is where we left off last time. So let's actually make this work the way we wanted here. We're going to export to our swap driver method. For the driver name here, we're going to send it old driver, which is Kevin here. Really, my variable names aren't real great. Let's do this. Let's call this newest driver. That'll make a little bit more sense. And newest age, and newest year's driving. And so the parameter new name will be set to newest driver. Pull this down to a new line here. New age will be set to newest age, and new year's driving will be set to newest YD. And then it's going to give me back the information on the old driver, and I've got to figure out where I want to put it, and for that I'll use these leftover variables up here that I have that we previously had Roberta in. And so the old driver will be put in driv name, the old age will be put in driv age, and the old year's driving will be put in driv yd. A lot of variables to keep up with this early in the morning, but I think I did that right. And so now, after the swap driver, we have just made Kevin the new driver, and our local variables, driv name, driv age, and driv yd, are holding Roberta's information. So the first thing we'll do, or the next thing we'll do here, is let's make sure that in fact we did swap in Kevin correctly by showing his information. So we should see Roberta show up in our output as the second driver, and then Kevin show up as the third driver. And let's see if in fact that happened. And we do. We see Kevin there as the third driver with his information. So our swap driver method seems to be working just fine. Then if we wanted to make sure we really did get back the information we were expecting here, we'll do this actually here in our local code, not in the method, and we will print out the driver as being, whoops, that wasn't what I meant to do, as being driv name, and we will print out driv age, and lastly we will print out
Is it okay
driv.
to put UI in the ShowDriver method?
We could, that gets to being a design thing. You could, for example, it would not be inappropriate even to do something like this, where let's find this. This is where I missed my really big screen here. In ShowDriver, we could even put a line and then output the driver and then put another line. We could do something like this. And so let's run it now. We're going to see where we have a double line in one place because of the U line that's in our procedural code. But this is what we have. Here's Bob being written to the screen, Roberta. Here's where we swapped Kevin in, and then here's the Roberta from our local code that shows that we did in fact get Roberta back. So what you're going to find is some of the things that are challenging when you're doing object-oriented programming is, as you can see here, as illustrated on lines 131 through 135, a lot of times you have a lot of variable names floating around, and you've got to keep track of everything. So it might be handy to have a piece of paper nearby where you're making notes to yourself so that you can keep everything straight. We haven't done a lot of this because ABAP code tends to be very self-documenting if you've written it properly, but it also would be very appropriate in the code that we're writing now to include comments that explain what particular methods do for the sake of overall clarity of code. So we left off actually with slide 16, where we made reference to something that we have not actually written any code for, and that is, we've talked about and we've illustrated, including just now in the work we did, importing, exporting, and changing. And we talked about this idea that we have to use these terms very carefully to make sure that what we have in the method definition, we use the inverse of it in the method call. And the idea being that if the method says that I'm importing information, then when I call it, because I'm sending it, I use exporting. The piece here that we've talked about but haven't written any code with is returning. And so let's talk about returning for a moment. Hopefully you remember that we mentioned that with returning, there was a special rule that we had to remember when we used that particular mechanism for data passing. What was the rule that went with returning?
It could only be with importing?
We can only have importing parameters, absolutely. So the idea here is let me find a whiteboard marker. The idea is that we're going to create a method where we can send it multiple pieces, 0 through n of importing parameters, and then it will pass back just one piece of returning data. And you'll recall, and this is a reason why I'm emphasizing this, is because sometimes this is what trips people up. The distinction here is with returning, I can only return one piece of data. One, or more precisely, I can return one data object. Now the fact is, that one data object could be a structure, that one data object could be an internal table, so it could be something very, very big, but it can only be one thing. I can't send back 3 structures, or I can't send back a structure and an integer. And so this is a kind of a special scenario that we have available to us. And the merit of this is, and we talked about it on a slide previously, is I can put this in an if statement. I could have a method call where I said something like this: if driv check, and maybe driv check is the name of a method in my object, which I'm just going to put here on the whiteboard, called D. So I have an object called D, and I call the driv check method. And the driv check method takes in one piece of information. It takes in a driver name. And so I pass it the driver name Bob. And because I only have importing parameters, and in this case, because driv check only takes in one parameter, I don't have to do all that stuff we were doing with the parameter name equals and whatever. This is a perfectly valid method call for a method that just takes in one importing parameter. And the idea here is this will return, let's say, the equivalent of if d driv check equals Bob. This will return, we'd say if driv check Bob equals 1, then we have code, else, and then we have other code, and then we have our end if. Well, in my driv check function, which we're just inventing here on the fly, my driv check function checks to see whether the current driver has the name of Bob. And if it does, it returns the value 1. If it doesn't, it returns a different value. We'll say 0, for example. So this is perfectly valid code for me to write using a method that has a returning value. Because what's going to happen here is this is going to be called, the return value is going to be grabbed, and that's going to be compared to 1 to see if in fact it's equal. I can't do this with an exporting or changing data object. I can only do it with something that is being returned to me. So let's go ahead and write this method that we just put here on the whiteboard as an illustration of this. And so I'll come back up here to where I am defining my interfaces, and we will create methods. Keep wanting to type methods this morning for some reason. Okay, and for some reason I'm having trouble seeing what's lined up here too, but we'll assume that's right. And what did I call that over there? Driv check? Driv check. And what this is going to do is driv check is going to be importing, and it's going to be importing a name of type string, And what do we use in the method definition to indicate we're sending data back? What's the keyword for that?
Export.
Well, exporting is one way of sending data back, but the way of sending data back with what's called a functional method, what's the keyword we use? It's on this slide. Returning. So I'm importing this and I'm returning, and we'll just call this returning result type I. Now, I have some...
You're missing a period.
Where am I missing a period?
An importing statement, but you're not supposed to have it, sorry.
Yeah, I'm not missing a period there because we don't put a period, but I have a problem here somewhere.
That's the top string.
What's this? It might not like this type string, but I don't think that's the case.
We did it above it, we didn't have trouble with the string.
Yeah, this is kind of curious. Let's go back and see what mistake I've made. Let's go back and look at our rules related to a functional method. Functional methods, those that return a value, the value to be returned by the method call be listed in the interface. Okay, so on the other end, we do this right here, and so I don't see any problem there. What's that?
There's parentheses.
Well, but this is when I'm calling it. We're back here at the method. We're back here at definition phase right here. So I have made an error, but I'm not seeing it at the moment.
Back on that other slide, it had, I think it had an additional something in that line, the return line. Do you have to set a variable for it or something?
Yep.
I wonder, let's check here and see if that's what it is. I think we just discovered something. Okay, so what's the significance of what we just did? What did that do? Pass by what?
That's by value instead of.
Okay, so the returning variable has to be passed by value. And so we saw that illustrated here. I don't have that in the slides, and so you might want to write that down. But in this case, this driv check method is going to take in a name, and it's going to give back a result, which is going to be this just an integer value, so type I. So let's put this, what I like to do is put this at the top of the screen so I can keep track of things, and then split the screen, and then come down here and write my implementation. I have tried to do this in my code. Once again, with this really small screen with everything so big here, it is a bit tricky, but the rule of thumb is you want your methods to be in the same order in both your definition and the implementation. So I'm putting this at the end here, and so this will be the method driv check and end method. And I'm going to have just some pretty straightforward conditional code here. If name, which is what I'm getting in as a parameter, is equal to, and then the name of my attribute is, we have a structure called, is it driver name? We'll have to make sure I'm using the right code here. Okay, yeah, so driver, the driver struct is what we're using here. So if name equals driver name, then I don't use the keyword returning or anything like that. What I do is I set the data object to a value. Result equals 1, else result equals 0, and and if. All right, so in my driv check method, it's going to take in a name, check it against the current driver's name. If they match, it's going to pass back a 1. If they don't, it's going to pass back a 0. Now, what this will allow me to do, and let me check my code to make sure we don't have any other mistakes here, but I don't see anything in red, so I think we're pretty good here. So let's just do this, because one of the things that we can do with a functional method is we can drop it into a write statement. So I can now say write, and the name of my data object here, well, I'll do this, put this on a new line, and I'm going to write out match question mark, and we're going to call my vehicle driv check, and we are going to pass it a name of a driver. Now, in fact, at this point in my code, I've kind of lost track of who the driver is. I think the driver is Kevin. Okay, so I'm going to do this: match Kevin question mark, and we'll do a driv check with passing it Kevin, and then we'll do another one here. Right, match rows. So what are we expecting to see as our results when these two lines are written to output? We should see a 1 for matching Kevin, assuming that we got the name right there, and we should see a 0 for matching rows. And in fact, that's exactly what we see. Okay? So the point is, with a functional method, we have only importing parameters. We have one returning data object, which we have observed has to be passed by value. And although we do not have to use it in this fashion, we pick up the ability with a functional method to drop it directly into a write statement, like I did here on the whiteboard, or to even drop it directly into an output statement, like I did here in our code in the editor. So that is something unique to a functional method, as is illustrated here on lines 45 through 47. Now, there are other ways that I can capture these returning values, and I made reference to it, I think, on slide 15. But let's review those real quickly before we head off into other things here. I could call it like the way I did the code just now, or I could call it more explicitly like what I'm doing here, where I do exporting P1 equals D1 and so on. The reason why I don't have to do that is because of what we talked about, where I only have importing parameters. But I can designate one receiving parameter and capture it this way. That is perfectly valid for me to do. But what is much more common is what we're seeing here in this last example, where this and what we did in the editor are the two equally common things, where I put the method call on the right side of an equal sign so that the return value gets captured in the specified data object on the left side of the equal sign. So I think in our example code now, we've worked through really all the different kinds of variations we might see in our types of methods. Any questions? All right, so we have one more thing to talk about in regards to methods, and that is a constructor method. Sure, you know what a constructor method is from your previous object-oriented programming experience. Let's talk about how it works in ABAP. A class may define a constructor method, and if it elects to do so, the name of that method is constructor. The method has to be public, so we know it's going to go in the public section of our class definition. And a constructor method can only have importing parameters. Okay? So we can't return anything, we can't have changing or exporting, it can only have importing parameters. The other thing about the constructor is we don't call the constructor explicitly. We don't put, my vehicle arrowhead constructor. It gets called automatically by the system when we create a new object. And constructors are very, very useful for initializing the attributes of an object. It can also be used for allocating resources for an object. It can be used to trigger other activities. Let me give you an example that you may find later has some relationship to your homework assignment. Maybe my class that I am defining is going to interact with the database table in the system database. And so the constructor method, or the method in, let me back up, the class has an attribute that's an internal table. And so what I want to have happen is when my particular object is created, I want that internal table to be filled up with information from the database table. Well, how do I do that? Well, I could use a constructor method, and the role of the constructor method will be to fill up the internal table by querying the database. Will I have to pass the constructor method anything? In the scenario I just outlined, maybe not. Maybe I just define a constructor method with no parameter passing at all, and in the body of that constructor method, I have it go out and query the database table and put the results in an internal table. As we look at the code that we have been creating here, the most common thing that we use a constructor variable for, or constructor method for, is to set initial values for the attributes of our object. So in this case, I have this driver who has a name, age, and years driving. And although we haven't used it very much, we don't want to forget about MPG, which is also an attribute that we have. So let's create a constructor method. And so I'm going to go here. Normally it is convention to make the constructor method the first method that you list. Don't necessarily have to write it first, but we usually put it at the very top of the list here. And as we said, you're almost always going to see importing parameters here with a constructor. And so I want to take in a name, which will be of type string. It does not like me using string, does it? But that might have been what we ran into. Oh, I was just missing the word type. Importing name, type string, age, type I, years driving, type I, and then MPG type. And I've forgotten what we used. Oh, it looks like MPG is type P. And by the way, I don't know that I've observed this previously, but notice here in my set MPG method, this doesn't say type P, length 3, decimals 2. We leave that just a generic type P and leave off the other elements in that, in our listing of data types here for parameters. Yes, sir.
You might have already said it, but does the
Constructor method always have to be called constructor?
Yes. Yep, it always has to be called constructor. Absolutely. So, yes, sir.
What format will that pack number get as just unspecified like that?
If you think through this, in my main program, I am going to create a data object of type P to pass in, most likely. So it is going to use that. Or if I pass in a literal value, which is what I'm going to do here in just a second, it will infer it from the literal value that it's passed. So that's kind of a nice little feature here. Now we're going to play around with this constructor method quite a bit because there are several things that are very important for us to know. But let's start out with it working just like we see it here. And what you're going to actually find is the constructor method in ABAP is very, very powerful, even though it's not necessarily complex. So here I have my method definition, so method constructor, and I'll go ahead and put in my end method statement. And my code here at this point really could not be any easier. I have an attribute called name, but well, actually my attribute is called what? Driver. So we would have driver dash name equals name, and then we would have driver dash age equals age, and driver dash years driving equals years driving. And now I'm glad we have this last one here as something different. If I write that code right there, MPG equals MPG. First of all, let's see if the system even complains about this. Yeah, I think it has. Let's look at its complaint and see what it says here. If I can get my split screen to work. The field MPG cannot be modified. No value was passed to the mandatory parameter name. Well, I haven't actually called it yet, so I think that's why we're seeing this second error. But this issue about the field MPG can't be modified, the system is having a hard time at this point disambiguating between the parameter, which is called MPG, and the fact that I believe we have an attribute in the private section called MPG. So how do I disambiguate which one of these is the attribute versus which one of these is the parameter?
Is it my or me?
Really close. It's me. And I do me with the arrowhead on the one of these that's the attribute. And it just so happens that's this guy right here. So looks weird and sounds even weirder when you read it. Me MPG equals MPG. Just seems like that should be my, but it's not. It's me. So this says the attribute MPG is going to be set equal to the parameter MPG.
Is that like Java's this Java?
Absolutely. It is exactly equivalent to this. In Java and other programming languages use this as well. Okay, so this is how we define a constructor. How do we actually call a constructor? Let's go back to our PowerPoint slides and look at that. We invoke the constructor as a part of the create object statement. So our code would look like this. Data object name, type ref to class name, create object, object name, and before we just had a period there because we didn't have a constructor. Now we see we have a constructor, so we put export and then we specify the values for each of the parameters.
Yeah.
Notice there's no parentheses used in anywhere in any part of this statement. So that makes this look really, really weird as a call to a method. But in fact, this is the call to the method for the object creation, the constructor. So let's incorporate this into our code. We kind of have to at this point because of the way we have defined this, and I'll come back and say more about that in a moment. So right here now, I have to change line 138. I have no choice but to change line 138. Can anybody tell me why I have to change line 138, or I'm going to get an error?
Because your constructor overrides any default constructor?
Well, that is a default constructor.
Well, in
But I
Java,
get it.
you know, I forget exactly what the term was, but if you don't have a constructor, then you have like a system provided one.
Okay, so if we stick with that line of thinking, so we now have a programmer-defined constructor. Tell me about what we observe about this programmer-defined constructor. What do we know about it?
As parameters.
Are they required or are they optional?
As written option.
They're required in the constructor.
Yeah, I mean, I don't see the word optional anywhere here. So the way I have written this, these are required. So this says, anytime I now create an object of type vehicle, I have no choice but to give it these things. That's why if I try and run this program right now, I am going to get an error because the system's going to say, hey, don't hold on a second, you have not given me parameters that I'm expecting to see. And in fact, it's just going to note it for the very first one. And it says, hey, hold on a second, you're creating an object on line 138 and you didn't set what name it's supposed to be. So one of the things that we're going to see here is, as this is written right now, all of those parameters are required. So let's go with that, and then we'll come back and play around with what some options could be here. So create object myVehicle, and exporting. Now, as we've already seen, I could do data objects here, or I could do literal values. So I'm going to do some literal values. Exporting name equals Kelly. Age equals 24. Years driving equals 7. And MPG of the vehicle equals 13.3. Okay, so now we should, in fact, let's do a syntax check and make sure we're good. No errors found there. So I'm going to do this. I'm going to use our good friend here now, myVehicle, what did we call this, ShowDriver? That shows us who's driving. And so we now should see that the very first driver is Kelly before any of the other code that we have written comes into play. And so sure enough, there's Kelly, age 24, who's been driving for 7 years. Miles per gallon isn't part of our ShowDriver method, so that's why that's not appearing there. So this is one way that we could structure a constructor. But as I hinted at a moment ago, if we think about this, some programming languages allow you to define multiple constructors. And the system will invoke whichever constructor matches the parameters that you pass to it. We don't have that option in ABAP. We don't have the ability to have multiple methods with the same name. But we can accomplish something very similar to that if we designate some of our parameters either as optional or if we specify default values. So, for example, I could say for driver, how do we specify a default value in a parameter? What's the keyword? Default, yeah. I mean, I kind of gave you the answer in the question. Okay, so we're going to say here, if we don't set a name, the default name will be no name. Okay? And for age, we're going to set this to just straight up be optional. And we're going to make years driving optional. And for miles per gallon, just to illustrate something a little bit different here, we'll make the default miles per gallon 18.8. Okay? Now, let me save this and do a syntax check real quick to make sure there's no typos. We're all good here. So let's explain what's going to happen. This constructor, as I've written it now, can I create an object and specify no attribute values whatsoever? Could I go back to just create object my vehicle period and have that be syntactically valid? Would that work?
Yes.
Yeah, I can do that now because none of these parameters are actually required. And if I do that, then name is going to be set to no name. The age will be left empty. Years driving will be left empty, depending on how I implement this in my code. And miles per gallon will be set to 18.8. But I could also invoke the create object method now and only set a name. Or I could set a name and a year's driving and leave age and MPG blank. Really, if you think about it, there's a whole bunch of ways that I could call this method now. What would it be? I could call it 4 factorial different ways, because I could specify 0 parameters, any of these as a 1. I could specify any pair of them. I could specify any 3 of them, or I could specify all 4 of them. I've got lots of different ways I can actually invoke my constructor method now. So what I am showing you here is extremely common for specifying that for a constructor, you either have default values for your parameters or you declare them to be optional. Now, what I haven't done here is I haven't talked about the implications of this in my writing of code for the constructor method. So let's go back up here and let's find the implementation of my constructor. And so here, okay, line 64, driver name equals name. Is there any problem with that? Well, if we just think about it logically, name will be set to a value. It's either going to be a value that has been coded in, name equals Bob or something like that, or if there is no name that's been coded in, the value of name is going to be set to no name. So line 64 is great as it is, but line 65 is kind of problematic. I might not have been given an age. Therefore, I can't put age on the right side of an equal sign. But what I can do is employ code that we have seen before. If age is not initial, driver age equals age. Now, the end result of this is that either age will be set to a value or age will be totally blank at this point. I could alternately do, if age is not initial, driver age equals age, else driver age equals 0. That would be even more explicit if I wanted to do something like that. So let's do that option with years driving. And I want to talk about this scenario. So if years driving, and if I use the name of this data object, years driving, without putting me in front of it, it's understood that this is the parameter that I was passed. So if the parameter years driving is not initial, driver years driving equals years driving, else years driver dash years driving equals 0. Okay, now let's do a syntax check, and you're really going to have to put on your thinking caps here for this next question, I think. First of all, anybody have any question about what's going on lines 68 through 72? Let me just walk through it. So the system's going to say, the parameter years driving, was it set to a value? Is not initial means it was set to a value. Oh, well, if years driving was set to a value, then I want to use it to assign my attribute to that particular value. Else, set my attribute years driving to 0. Do we understand that? So let me ask you this. How could I write this same logic, but a lot easier?
Default in the definition.
If and let's think about what we have observed here already here with, did we observe this with name? You know, with name, let me scroll up a little bit here in the top panel. Name has a default value specified. So if I have a default value specified, I can just write line 64 the way it is. And I know that that means that either name is going to be set to an explicit name or it's going to be set to no name. Now, as it turns out though, if I know that for years driving, I either want it to be set to a value or I want it to be set to 0, couldn't I just put years driving type I default 0? And the answer is yes. And I could get away with then just having the equivalent of line 64 for years driving instead of having this conditional code. Now the fact is, there are some times you might be able to come up with where you want to use an optional statement and have more sophisticated logic. Hypothetically, we might want to say, okay, if years driving hasn't been set, then let's look at the car's miles per gallon and set the number of years driving equal to 7 times the miles per gallon. Right? That makes no sense as an algorithm. But maybe you need to do some kind of calculation or something sophisticated, and you can't do a calculation in a default statement. So if you find yourself in that situation, you have to resort to the code like I've written here in lines 68 through 72. And there's nothing wrong at all with the code that I have written on lines 68 through 72. But isn't it just a lot easier to specify a default value and write one line of code and you get to the same exact destination? Any questions about this? All right, so let's play around with the call to this just to make sure we understand, and then we will be pretty close to wrapping up our initial discussion of ABAP Objects. So what this means is now I can go down here and I can go back to create object my vehicle period, and I'm going to tell my editor here just to comment out these lines right here so they don't exist anymore. And so when we show the driver now, we're going to get the default values. We're going to get from the default constructor no name with an age of 0 and years driving of 0. Or I could do this, exporting name equals Kelly. Oh, but when I use the default constructor, notice this, it changes a little bit. How do I call the default constructor? Exporting name equals value. But I get rid of that period right there. So now I should still get the 0 and the 0, but I'm going to get that the driver's name is Kelly. And in fact, we see that. Or, and just to not, we're not going to run through all the scenarios here for sure, but I could do this. I could get rid of setting Kelly, and I could say, let's just set the age. That's all I care about. In my program, all I want to do is set the age here. And so now, whoops,
Missing a period after age.
thank you. So now I get no name, which is the default, but I have years driving set to 24. Questions about any of this? All right, we have 15 minutes left, which probably is just enough time to cover the last thing for us to talk about. Static attributes. A static attribute is an attribute whose value is shared among all objects in a class and is not dependent upon instantiation. In my program that we have right here, if I created 3 vehicle objects, vehicle 1, vehicle 2, and vehicle 3, every one of those drivers would have its own distinct name. Vehicle 1 could be driven by Bob, vehicle 2 could be driven by Kelly, vehicle 3 could be driven by Sue. The attributes that we have worked with so far, when I instantiate an object, every one of those objects gets its own independent attributes. A static attribute gives us the ability to create an attribute that is shared amongst all of these. So there's only one that all of them have, and all of them therefore have the same value set. The most common use for a static attribute would be something like a counter, a vehicle counter that keeps track of how many vehicles that have been created. And the idea might be that in my constructor, I increment the counter. So the very first time I create a vehicle, the counter gets incremented to 1. I create another vehicle, it gets incremented to 2. I create another vehicle, it gets incremented to 3. If I ask any one of these objects, how many vehicles are there? It could check its counter and say the answer is 3. Because all of these are sharing that exact same attribute. Since the data belongs to the class and is shared among the objects, the code I use for this is, instead of having a simple data statement, I have a class data statement. So we've seen in the definition before, in either the public or the private section, we've seen a data statement before where we've created attributes. All we're doing here now is we're calling this class-data, and that means that all of the instantiations of, in this case, example class, will share that exact same attribute. You can use a default value here, just like we have seen with other attributes. You can do class, name, type, whatever, value, whatever, to specify a default value. The only thing that is distinct about a static attribute is the syntax we use to refer to it, but we will come back to that. Any questions about this so far? Do you understand the concept of a static attribute? This can be tricky, but if you've worked with these before, you either understand it or not. So do you understand what I'm talking about when I say a static attribute? See, a lot of people shaking their head yes. Other people are holding their head very, very still on purpose, which I don't know how to interpret that. So let's keep going for the moment. I can also create a class method. Now, a class method looks every bit like a regular method, only instead of the keyword method, it's going to use the keyword class method. But what's unique about a class method is these methods can only access static attributes. So you might say to yourself, why do I need class methods? What would be the value of this? Well, what if we wanted to create a very different kind of class than what we've seen before? What if we wanted to create a class called math? And we wanted to have a method in math, let's say called square. And square would take in a numeric value and return the square of that value. Pretty straightforward. Let's assume we wanted to do this. And in our math class, we also wanted to do square root, and we wanted to do factorial, and we wanted a variety of other kinds of mathematical calculations in here. What I could actually do is I could define a math class and have all of these be class methods, which means I wouldn't have to instantiate the math object. I wouldn't have a create object math kind of statement. I would just start using the math object. And as we'll see here in a moment, the way I would do this is instead of using an arrowhead, I use an equal sign arrowhead. And so I could say math square 17. And I'd probably want to put that on the right side of an equal sign, so it would be something like x equals math square 17. I can do this using class methods. That's the purpose of this alternative. Now, I'll be honest with you, in the kind of code that we're going to write, well, particularly in the kind of code you're going to write for your next homework assignment, there's nothing there of that sort for you to have to worry about. But we'll talk more about this on Monday. I did want to take just a second, though, and look at your homework assignment very quickly so as to deal with any kind of comments I might want to make or other things of that sort. So give me a moment here to get this pulled up. You're going to be writing a lot of code for this homework assignment, so start early. But a lot of the code is going to be somewhat redundant in its structure. Let's just pull up the Word document version of this. Okay, so you're going to create a class that allows a user to indirectly work with the database table SPFly. And one of the things that I put here at the top, I should have put this in like a bright red flashing box, but I didn't. You're going to copy the SPFly table into your own database table that starts with your username. So you're going to have to make a copy of that database table using the technique that we went through in class a couple of class periods ago. And you're going to use that in lieu of the SPFly table. And this is a very common thing for us to do in ABAP development when we're working on something and we don't want to disrupt the system table. We make our own copy, we get the program working right with our copy of the table, and then when we're ready, we change it so it actually uses the system database table. But in this case, because you are going to be doing some manipulation of the database table, I don't want your work to interfere with the work of another student. So I have asked you to create a set of methods here. Show from country flights, show city flights, get con-ed data, get con-ed, get flight time, and you'll see there are descriptions of each of these. Some of these methods may be a couple of lines of code. Some of these methods may be 6 or 8 lines of code. But you're going to be writing a set of methods for this particular class. Really, where most of your code is going to come into play, however, is you're going to have to create a program that tests this class and shows that each of the methods work correctly. Now, there's one piece of advice here that I give, and I wanted to emphasize this is, my encouragement to you is, pick a method, write it. Then write the code to test that method and make sure it's working correctly. Then move on to the next method. And I think if you bounce back and forth in your coding in that fashion, this will be a lot easier for you to accomplish than to try some kind of big bang coding approach where you write all the methods and then you write all the testing cases and you try and get them to work in conjunction with one another. Get started on it early so that if you run into questions you can ask them, but this homework assignment is worth a good bit of points, but you should find it to be a very good practice of the things we've been talking about for the last couple of class periods. Are there any questions about the homework in general or anything we've talked about today in general?
You think it'll be worth as much as the last homework?
I think the last homework was worth 50 points, and I think this one's worth 60, so it's actually worth a little bit more. And by and large, the class did well on the last homework assignment, so keep that up. The reason why I'm giving you homework with lots of points is for those of you that are seeking improvement in your grade, this will give you that opportunity. And it also takes a little bit less of the stress off of the final exam if you accumulate more points between now and then. Okay? Other questions?
You had previously mentioned the possibility of like an extra credit.
Yeah, there will be probably a couple of optional extra credit programs, and if I get time between now and Monday, you may see the first of those available to you on Monday of next week. All right, well, have a good rest of the day, everyone. If you didn't sign in, make sure you do that before you head out, and I'll see you guys when we get together next week.